So, I heard a few of you are looking for answers and solutions to a couple of my math treats. I'm really excited to hear that. I am here to maybe give away some answers to a couple. So one was how many squares. So I think the problem setup was we had 16 dots in a 4x4 array, and you were trying to find how many squares can you make where all of the dots, all of the corners of the squares lay on one of these dots. So I think most people will notice that you have a square here, and you can probably quickly see that there are 9 of these this size. I'll call this a 1x1 square because each side length is sort of 1 unit long, and we can probably tell that there's 9 of those. All right, cool. Then you move on, you say, okay, I can see some bigger ones that look like this. And if you stare at that for a while, and we'll call that a 2x2, I think you could probably convince yourself there's 4 of those. And a lot of people notice right off that the whole thing is a square all the way around, and we'll call that a 3x3. And if you got this far, you're doing great. Now, the challenge was though, believe it or not, there are more squares in here. And in my hint video, I said something about either tilting your head to the side to get a new perspective, or taking these and kind of rotating them, especially if you have them on a piece of paper, just rotating them and kind of staring at it to see if you see any other squares. So if you haven't done that yet, do that now. Pause the video, do that, try it, give yourself a couple minutes, and then, and only then, unpause the video, and I'll share with you the next little secret. Okay, so if you rotate this and look at it from a different perspective, you might start to see that, you know what, all my lines don't have to be horizontal and vertical, they can be diagonal. So maybe I go like this, and then I notice that, oh gosh, you can do that. And with a little investigation, you should be able to convince yourself that that is a square. All the side lengths are the same, and if you can prove these are 90-degree angles, then that is indeed a square. Once you see that, you can probably imagine shifting it around, and I think there's 4 of those. So what will I call that one? Well, if you know the quadratic formula or anything, this side length is actually the square root of 2. So that might be a news for another math trait. Maybe I could do it by the area of this instead. How do you find the area of this thing? For me, the easiest way to do it is to kind of think about these lines right here and notice that this triangle right here is half of this square. So the area of that is 1/2 plus a half plus a half plus a half. So this is an area 2 square, and I think we just said there's 4 of them. So now we're up to 18 squares in this grid, and if you got that far, that's fantastic. But now that we know we can make diagonal lines, we should probably investigate other diagonal lines. So let's see. Let's get rid of this so it's not too messy. Now, that line I had before was kind of like 1 up and 1 over, right, to make this line. That's how I might think about it. So let me not do 1 up and 1 over. Let me do 1 up and 2 over, kind of like a knight moves in chess, if you're familiar with chess. And if I do that, then I want to do the opposite after that. So I'll go over 1 and down 2 to get there, and then down 1 and over 2 to get here, and then over 1 and up 2 to get there. That certainly looks square-ish. You need to prove and convince yourself that indeed it is if you want to include it. And so there's, if we include that one, that gets us from 18 to 19. And I don't think you can move this one around, right? Because it starts on one edge and sort of ends on the other edge. So you can't move it up and down, left and right. But could you find a rotation of it? And then how many of those are there? So I think I'll stop there. I don't think you can go more than this with your angles. Remember, we did 1 up and 1 over, and we did 1 up and 2 over. So another thing to try would be 1 up and 3 over. Let's try that and just see where that goes. Because we do need to convince ourselves when we're done. How do we know we've finished finding them all? 1 up and 3 over would be like this, and then I would have to go 1 over and 3 down, which would be outside of the grid. So if I made a bigger grid, this square would exist, but in this grid, it doesn't. So that's out. Another thing you could try is up 2 and over 2. So I need to start here maybe and go up 2 over 2 like this. And again, that would get me to here. No, that's not going to work, right? That's not the right line. And then if I go down 2 and over 2, again, I'm off the grid. So I think we have identified all the squares, at least 19, maybe a couple more if you can see those. So I don't like to ever give the final answer, so I won't tell you, but I think you should be pretty confident with what I've given you so far to know that you're there.